What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Is what the People's Commissar of Defense S. K. Timoshenko wrote to the chairman of the Defense Committee under the USSR Council of People's Commissars K.E. Voroshilov in December 1940, the main reasons for the extremely difficult situation with the means of mechanical traction in artillery units are a. The lack of special plans for the production of artillery tractors, and the conversion of agricultural tractors into artillery tractors at existing tractor factories does not give positive results. B. The lack of special design bureaus for the development of artillery tractors. C. The lack of special design bureaus for the development of artillery tractors. The shortage of the towing fleet in the Army, the frequent discrepancy between the actual capabilities of the tractors and the characteristics of the towed guns, and finally, the rapid advance of the Wehrmacht deep into the country led to the fact that during the summer retreat, the Red Army lost about 2,000 guns of 122, 152 and 203 mm caliber. Most of the remaining machines were urgently sent to the rear in order to save them from destruction and not to aggravate the existing shortage. They were almost never used in combat operations until the counteroffensive operation near Moscow. During the initial period of the war, the Red Army lost a large number of artillery tractors. The situation on the fronts was changing. The Red Army was moving from retreat to counterattack. By the summer campaign of 1942 for transportation of artillery systems of special power, which were at the disposal of the reserve of the Supreme High Command, needed powerful tractors with high traction qualities. Otherwise it was simply impossible to conduct an offensive. First of all, we needed a relatively compact tractor capable of towing up to 9 tons. The contractors were found quickly. They were ZIS and the Tractor Research Institute, NATI, which had previously worked in tandem to create the Army half-track tractors ZS-42 and ZS-42M. The deadline for everything, development and serial production, was incredibly short, 3 months. It was possible to fulfill this archaically complicated task only by using the products of the existing production. And since that was the case, the engine, transmission, and front axle were selected from the ZIS nomenclature, and the undercarriage was unified with the T-70B light tank. One of the aggregate donors for the new half-track tractor was a ZIS 5V 3-ton truck. The choice of the half-track tractor designation, A8, the index was given on the basis of the weight of towed systems, had its own reasoning. The vehicle of this type is stable on the road, does not sway and allows to mount special superstructures. In the design it is possible to fully use automotive parts and transmission units. The hood layout with the engine above the front axle provides large dimensions of the body and makes the tractor more versatile. In addition, the steerable wheels do not destroy the road surface when cornering. The main problem was the lack of a serial engine for the AT8 with a rated output of at least 150 to 160 horsepower. For this reason, when designing their own version of the tractor, NATI engineers could not use the inline 6-cylinder overhead valve engine MB27, 10.3 litres, with an output of 155 horsepower developed at the Institute before the war and a manual 3-speed gearbox working in tandem with it. These units remained experimental, although they proved themselves quite well on the experimental city bus NATI A. The experience of work on the twin-engine truck YAG NATI 2M came in handy when creating the AT8. Here the experience of designing the experimental twin-engine truck YAG NATI 2M, 6x4, in the work on which B. Fidderman was also involved, came in handy. Fidderman. The truck, built in 1933, was equipped with 2 AM03 engines and 2 transmissions, each of which transmitted power to its drive axle using Brown-Lipe 35 gearbox and demultiplier of NATI design. A common lever was used to control both transmissions. Parallel arrangement of engines on the YAG NATI 2M under a single hood 2-engine AT8 half-track tractor. The machine felt itself confidently on rough terrain to facilitate turning the impact on the belt transmission brakes, with foot and manual control, mounted on the shanks of the main gears, was carried out separately on the right and left sides. Without a trailer, the tractor could climb a steep 34° hill. The front axle was equipped with a dependent suspension on semi-elliptic leaf springs and oversized tires with developed ground serrations. In addition to the chain drive wheels with removable toothed crowns from the T-70B tank, the tractor got the sloths equipped with a track tensioning mechanism and 4 single-slide support rollers on each side, with a diameter of 550 mm with rubber bands unified with them. The upper branch of the 300 mm wide fine link caterpillar was supported by 3 small support rollers on each side. The suspension was individual torsion suspension without shock absorbers. This design provided the vehicle with good smoothness on off-road. Driving on a slope with a folding tailgate, which could accommodate 2.5 tons of cargo or 15 people. Curb weight of the tractor without cargo and fuel was 7 tons, width 2,550 mm, length about 6.5 m, the minimum ground clearance. Under the steer axle beam, 380 mm. Load on the front axle, without load, 1.92 tons, on the crawler tracks respectively, 4.87.5 tons. In general, the main thing that distinguished the AT8 from its predecessors was its significantly lower weight and higher payload. The AT8 prototype was designed and built during October-December 1942. Tests of the machine took place in the spring-summer of 1943. Already from the very beginning the tractor showed impressive results, which spoke about the correctness of the solutions put into its design. With the ML20 the tractor could move on the muddy ground. Towing an artillery system weighing 9 tons, the AT8 with 2.5 tons of cargo in the body moved confidently on all types of roads and off-road. The maximum speed with a full load reached 28 km per hour, the average speed when driving on the highway, 20 to 21 km per hour. The highest climb with a 9-ton trailer was 20 degrees, without a trailer, 34 degrees. The machine could move on a 30-degree slope. Average specific pressure of the Caterpillar without load, 0.36 kgf/cm and with a load, 0.47 kgf/cm. 2. On the highway, the fuel consumption of the train weighing 18.5 tons was in the region of 160 L/100 km or 1.2 kg per kilometer of travel. Transportation of 203 mm howitzer B4 with dismantled barrel. Some deficiencies were also found. Among them were insufficient tractive effort on soils with low coefficient of grip, rather low strength of the carrier frame and half axles. There were cases of gearbox failure at extreme operating modes. Traction capabilities of the AT8 allowed to create a new, more perfect machine at the same time. The tests revealed a large power reserve, which gave grounds to continue work on an improved version of the tractor, designed to work with trailing systems weighing 1Z14 tons. The main difference of the AT14 tractor was the extended crawler propulsion system to improve running characteristics. Each crawler received a 5th support roller and the tracks received rubber shoes. This resulted in a larger footprint. Due to the fact that the front part of the crawler track was moved closer to the steering axle, the overall length of the tractor did not increase. 3 gas tanks with a total capacity of 315 litres with separate fuel supply to the engines moved to the front of the body, which was moved close to the rear wall of the cabin. Attachment of the towing and coupling device from the rear frame crossmember was moved to the elastic element in the form of leaf springs, which reduced dynamic loads during towing trailers, especially when moving and braking. The spare tire was placed on the side of the load platform. Cargo and people could be protected from bad weather in the body by removable arches and awning. Other components of the design were practically unchanged. After modernization, the curb weight of the truck increased to 8 tons. 2. The new tractor has a spare tire, which was mounted on the side of the body in the winter of 1944 at the plant, and in the spring and summer at the test ranges. The AT14 was subjected to comprehensive tests. The obtained characteristics were quite convincing. Traction on the hook when driving on snow reached 3.9 tons, on the ground, 7.5 tons, on asphalt, 6.2 tons. On the highway, the machine, towing a 14-ton trailer, accelerated up to 25 km per hour. The average speed was 18 km per hour, and on a country road, 8 to 12 km per hour. In the asset of the machine, overcoming 14-degree rises and fords with depth up to 0.8 meters. With a load in the body, but without a trailer it was possible to climb up to 30 degrees. The average specific pressure of the crawler with a load in the body was in the region of 0.5 kgf/cm. The range with a full load is 225 kilometers. AT14 layout and its overall dimensions. In conclusion, the evolution of crawler tractors within the Red Army highlights a significant advancement in military logistics and agricultural support during the years that followed. With models like the Komsomolets and Voroshilovets demonstrating impressive towing capacities, the Red Army was able to enhance its operational efficiency. However, while these agricultural tractors provided valuable assistance, they fell short of the reliability and speed offered by specialized tracked vehicles. This development underscores the ongoing need for innovation in military machinery to meet the demands of warfare effectively.